June 14, 1944. Near Villers-Bocage, Normandy, the German reconnaissance column moved cautiously through the narrow French countryside, their SDKFZ 222 armored cars leading a convoy of half-tracks and supply trucks that carried ammunition and reinforcements toward the expanding Allied beachhead. Oberleutnant Franz Weber commanded the lead vehicle, confident in its 14.5 mm armor plating that had proven effective against Allied small arms fire throughout the campaign. The morning mist provided additional concealment as his column approached what intelligence reports indicated was a lightly defended American position. Weber's armored car represented the latest in German reconnaissance technology, featuring sloped armor designed to deflect rifle bullets and machine gun rounds while providing excellent mobility across difficult terrain. The vehicle's crew of 4 had survived multiple engagements since D-Day, their experience teaching them to respect Allied anti-tank weapons while maintaining confidence in their protection against infantry weapons that seemed inadequate compared to German engineering standards. The hedgerow country of Normandy had proven challenging for both sides, creating a battlefield where small unit actions determined tactical success more often than grand maneuvers involving entire divisions. Weber's mission was straightforward: probe American positions, identify weak points, and report back to enable larger German forces to exploit gaps in Allied defensive lines that were still consolidating after the massive amphibious assault that had surprised German command. Suddenly, the morning silence shattered with a sound unlike anything Weber had experienced in 3 years of combat across multiple theaters. A deep mechanical roar erupted from behind an American position concealed in the thick Norman hedgerows, followed immediately by the distinctive crack of heavy bullets traveling at supersonic velocities. The sound was not the rapid chattering of conventional machine guns, but something far more ominous, a measured, devastating rhythm that seemed to shake the very air around Weber's vehicle. The first burst of 50 caliber bullets struck Weber's armored car with force that exceeded every assumption about infantry weapons and their limitations against armored vehicles. The massive rounds, each weighing 1.76 ounces and traveling at 2,900 feet per second, punched through the vehicle's side armor as if it were made of paper rather than hardened steel. Weber watched in horror as his radio operator collapsed, killed instantly by a bullet that had penetrated the armor, ricocheted off internal components, and torn through the cramped fighting compartment with devastating effect. The second burst disabled the armored car's engine and transmission, sending clouds of steam and oil across the road while fragments of destroyed mechanical components flew through the air like shrapnel from an artillery explosion. Weber realized with growing terror that his supposedly protected vehicle was being systematically destroyed by what appeared to be infantry weapons, firing from positions he couldn't even see clearly through the thick vegetation that characterized the Norman battlefield. Behind Weber's disabled armored car, the rest of the German column encountered the same devastating firepower as additional American machine gun positions revealed themselves through muzzle flashes and the distinctive sound signature of weapons that seemed to exceed every German assumption about Allied infantry capabilities. Half-tracks that had provided reliable protection against conventional small arms fire found their armor penetrated by rounds that tore through steel plating, destroyed vital components, and killed crew members with shocking efficiency. The German column, that had approached the American position with confidence based on superior armor and proven tactical doctrine, found itself immobilized and decimated within minutes by weapons that appeared to combine the destructive power of light artillery with the rapid deployment and tactical flexibility of machine guns. The psychological impact was immediate and devastating. German forces were encountering American capabilities that exceeded their intelligence estimates and tactical preparation. What would you have done facing a weapon that even shredded your armored vehicles? The Browning M2 .50 caliber machine gun represented the culmination of American firearms genius embodied in the work of John Moses Browning, whose innovative designs had revolutionized military small arms throughout the early 20th century. Browning's original heavy machine gun design emerged during World War I as American forces recognized the need for weapons capable of engaging both personnel and light armored targets at ranges that exceeded the capabilities of conventional infantry weapons available to Allied forces during the trench warfare that characterized the Western Front. The development process began in 1918 when American military planners observed that existing machine guns, while effective against personnel targets, lacked the penetrating power necessary to engage the increasingly armored vehicles and fortifications that were beginning to appear on European battlefields. Browning's solution was characteristically elegant: scale up his proven machine gun design to accommodate a much larger cartridge that could deliver dramatically increased kinetic energy while maintaining the reliability and ease of manufacture that had made his previous designs successful. The .50 caliber cartridge itself represented a significant advance in ammunition technology, featuring a massive 661-grain bullet propelled by 232 grains of powder to achieve muzzle velocities exceeding 2,900 feet per second. This combination delivered kinetic energy levels that approached those of small artillery rounds while maintaining the accuracy and consistency necessary for effective machine gun employment. The cartridge was powerful enough to penetrate light armor, disable vehicle engines, and destroy equipment at ranges exceeding 2,000 yards. Manufacturing challenges for the M2 system were enormous, requiring precision engineering and quality control standards that pushed American industrial capabilities to their limits during the interwar period when military budgets were severely constrained and demand for heavy weapons remained minimal. The weapons receiver had to withstand chamber pressures and recoil forces that exceeded those of any previous machine gun design, while maintaining the precise tolerances necessary for reliable automatic operation under combat conditions. American industrial capacity during World War II enabled mass production of M2 machine guns on scales that exceeded the wildest pre-war projections, with manufacturing facilities producing thousands of weapons monthly, while simultaneously developing improved versions optimized for different tactical applications. The basic M2 design proved so adaptable that it could be configured for infantry use, vehicle mounting, aircraft installation, and anti-aircraft employment, with minimal modifications to the core mechanism. The tactical versatility of the M2 system exceeded that of any comparable weapon available to any military force during World War II, providing American units with capabilities that ranged from long-range precision fire against personnel targets to effective engagement of light armored vehicles and low-flying aircraft. This flexibility meant that American forces could employ M2 weapons in virtually any tactical situation where heavy firepower was required, creating significant advantages in combined arms operations. German intelligence services had observed American M2 development throughout the interwar period, but consistently underestimated the weapon's tactical significance and combat effectiveness based on European assumptions about the proper role of machine guns in modern warfare. German doctrine emphasized rapid-firing weapons like the MG-34 and MG-42 that could deliver high volumes of fire against personnel targets, while the American approach focused on fewer, more powerful weapons that could engage a wider variety of targets. The production scale achieved by American manufacturers exceeded German capabilities by enormous margins, enabling deployment of M2 weapons throughout American military units at organizational levels that German planners considered wasteful and unnecessary. While German forces typically employed 1 or 2 heavy machine guns per company, American units routinely fielded multiple M2 systems at platoon and squad levels, creating firepower densities that German defensive planning had never anticipated. Training programs for American M2 crews emphasized the weapon's versatility and encouraged innovative tactical employment that maximized its unique capabilities against diverse target types. American gunners learned to engage everything from individual snipers to light-armored vehicles with equal effectiveness, while German machine gun training focused primarily on anti-personnel employment that limited tactical flexibility and reduced overall combat effectiveness. The psychological impact of M2 employment was carefully studied by American military psychologists who recognized that the weapon's distinctive sound signature and visible destructive effects created fear and demoralization among enemy forces that exceeded its purely physical capabilities. The deep, rhythmic firing sound was unlike anything produced by conventional machine guns, while the massive muzzle flash and visible bullet impacts created intimidation effects that multiplied the weapon's tactical value. American logistical systems were specifically designed to support M2 employment through specialized ammunition supply chains, maintenance procedures, and replacement part availability that ensured consistent weapon performance under the demanding conditions of sustained combat operations. The massive .50 caliber ammunition required significant logistical resources, but American industrial capacity made such support feasible on global scales that German forces could never match. The strategic implications of widespread M2 deployment became apparent as American forces demonstrated capabilities that exceeded German defensive assumptions and tactical planning throughout the European campaign. German commanders found themselves confronting American units whose firepower and tactical flexibility surpassed anything in their experience, forcing fundamental revisions to defensive doctrine and operational planning that came too late to influence campaign outcomes. June 16, 1944, 14:30 hours, Koma, Levante, Normandy. Staff Sergeant Mike O'Brien positioned his Browning M2 machine gun behind a hastily constructed sandbag emplacement that overlooked a crucial road junction where German forces had been attempting to establish a defensive line for 3 days. The massive weapon weighed 84 pounds without its tripod mount, requiring a 3-man crew to operate effectively. But O'Brien knew from training that the M2's devastating firepower would justify every ounce of weight and logistical complexity required to deploy it in forward positions. The German defensive position consisted of infantry trenches supported by 2 SDKFZ 251 half-tracks that provided mobile fire support while maintaining the ability to withdraw rapidly if American forces attempted to outflank the position. German commanders had positioned their vehicles hull down behind earth berms that concealed most of their profiles while providing clear fields of fire across the approaches that American forces would have to use for any assault on the position. O'Brien's assistant gunner, Corporal James Rodriguez, fed the first belt of .50 caliber ammunition into the weapon's receiver, while Private Tommy Chen prepared additional ammunition belts and maintained watch for German movement through his binoculars. The M2's ammunition consisted of alternating armor-piercing and high-explosive incendiary rounds that could penetrate light armor while creating secondary fires and explosions that multiplied the weapon's destructive effects against vehicles and equipment. The German half-tracks represented formidable opponents for conventional infantry weapons, featuring 14 5mm frontal armor, and 8mm side protection that could deflect rifle bullets and light machine gun rounds while providing protected transportation for full infantry squads. The vehicle's 7.92 MG-42 machine guns delivered rapid-fire suppression that had proven effective against American infantry advances throughout the Normandy campaign, creating tactical situations where American forces required heavy weapons support to achieve breakthrough objectives. O'Brien's first target appeared as a German SDKF Zu-251 moved forward to provide covering fire for infantry, attempting to reinforce their defensive positions. The half-track's commander apparently believed his vehicle's armor provided adequate protection against American infantry weapons, exposing his vehicle's side armor as he maneuvered to achieve optimal firing positions. O'Brien adjusted his weapon's elevation and windage while calculating the range at approximately 800 yards, well within the M2's effective engagement envelope. The first burst from O'Brien's M2 consisted of 15 rounds fired in a 3-second sequence that demonstrated the weapon's devastating accuracy and penetrating power. The massive 50 caliber bullets struck the half-track's side armor with kinetic energy exceeding 13,000 foot-pounds each, punching through the steel plating and creating secondary damage as bullet fragments and spalling ricocheted through the vehicle's interior compartment, where crew members had no protection against such devastating attacks. The armor-piercing rounds penetrated the half-track's fuel tank, creating massive fires that spread rapidly through the vehicle's interior, while high-explosive incendiary rounds detonated stored ammunition and created secondary explosions that completed the vehicle's destruction. Within seconds, the German half-track was transformed from an effective fighting platform into a burning wreck that provided no protection for its crew members, who abandoned their vehicle while struggling to escape the flames and explosions that continued erupting from their destroyed equipment. German infantry in nearby trenches watched in horror as their supporting armor was systematically destroyed by weapons they had assumed were incapable of engaging armored targets effectively. The psychological impact was immediate and devastating. German soldiers realized that their defensive planning had been based on incorrect assumptions about American infantry capabilities and the protection provided by light armored vehicles that they had considered immune to small arms fire. O'Brien's second target was the remaining German half-track, whose crew had observed the destruction of their companion vehicle and attempted to withdraw to positions that would provide better protection against the devastating American fire. The German vehicle commander tried to use terrain features and smoke to conceal his movement, but the M2's long-range accuracy and penetrating power made concealment ineffective against an enemy who could engage targets at distances exceeding 1,500 yards. The second engagement demonstrated the M2's versatility as O'Brien shifted his fire between the moving half-track and German infantry positions that were attempting to provide covering fire for their withdrawing armor. The weapon's ability to engage multiple target types with equal effectiveness created tactical flexibility that German defensive planning had never anticipated, enabling American forces to neutralize both personnel and vehicle threats simultaneously. Rodriguez maintained steady ammunition supply, while Chen provided target identification and range estimation that enabled O'Brien to achieve first-round hits against targets that would have required multiple engagements with conventional weapons. The crew's coordination reflected training programs that emphasized teamwork and rapid target engagement, enabling maximum utilization of the M2's devastating capabilities against diverse target arrays. The second German half-track attempted to return fire with its MG-42 machine gun, but the 7.92mm rounds lacked the range and penetrating power necessary to engage O'Brien's position effectively. The German weapons' rapid cyclic rate created impressive sound effects, but achieved no meaningful results against American positions that were protected by sandbags and positioned beyond effective engagement ranges for conventional machine guns. O'Brien's response was swift and devastating. A sustained burst of 37 rounds destroyed the German half-track's machine gun mount, penetrated the vehicle's armor in multiple locations, and created fires that forced immediate crew evacuation. The German vehicle's ammunition storage detonated in a series of explosions that sent fragments and debris across wide areas, while creating smoke clouds that marked the position for additional American units advancing toward the German defensive line. The psychological impact on German infantry was profound and immediate. Soldiers who had relied on armored support found themselves isolated and vulnerable to American advances that they lacked the firepower to repel effectively. The M2's demonstration of capabilities that exceeded German assumptions about American infantry weapons created fear and uncertainty that spread throughout the German defensive position, disrupting coordination and reducing the effectiveness of organized resistance. German attempts to suppress O'Brien's position using conventional infantry weapons proved futile against an enemy who possessed superior range, accuracy, and destructive power. The M2's ability to engage targets at distances exceeding 2,000 yards meant that German forces could not achieve effective return fire using weapons designed for closer-range combat against personnel targets rather than long-range precision engagement of fortified positions. The engagement continued for 47 minutes, as O'Brien's crew systematically destroyed German equipment, suppressed infantry positions, and provided fire support for advancing American forces who exploited the gaps created by heavy machine gun fire. The M2's sustained firing capability enabled continuous pressure that prevented German forces from reorganizing their defenses or establishing new positions that could resist American advances. By 15-17 hours, the German defensive position had been completely neutralized, with both supporting vehicles destroyed and infantry positions abandoned by survivors who could no longer maintain organized resistance against American forces equipped with weapons whose capabilities exceeded every assumption about infantry firepower and tactical flexibility. The M2 had achieved tactical success that conventional weapons could not have accomplished without significantly higher ammunition expenditure and extended engagement times. Within hours of O'Brien's devastating engagement at Koma, Levante, German military communications began carrying alarmed reports describing American infantry weapons that possessed capabilities far exceeding anything documented in German intelligence files or combat experience from previous campaigns. Field commanders transmitted urgent requests for information about American supermachine guns that could penetrate armor and destroy vehicles at ranges that seemed impossible for infantry portable weapons. German intelligence officers initially dismissed these reports as combat exaggeration or misidentification of American anti-tank weapons. But the consistency and detail of multiple independent accounts forced recognition that American forces had deployed new capabilities that challenged fundamental assumptions about infantry weapons and their tactical limitations. The reports described weapons that combined the penetrating power of anti-tank guns with the sustained firing capability of machine guns in ways that German doctrine had never anticipated. The psychological impact on German forces was immediate and profound, creating fear and uncertainty that spread far beyond units that had directly encountered M2 fire. Stories of American machine guns that could punch through armor like paper circulated through German communication networks faster than official intelligence reports, creating psychological pressure that affected German defensive planning and troop morale across entire sectors of the Normandy front. German medical facilities began receiving casualties with wounds that exceeded anything previously documented from conventional machine gun attacks. The massive 50 caliber bullets created traumatic injuries that challenged German field medical capabilities, while the psychological trauma associated with surviving M2 attacks created new categories of combat stress reactions that German military medicine struggled to treat effectively. American commanders quickly recognized the strategic value of psychological warfare effects that M2 employment created among German forces, leading to expanded deployment of 50 caliber weapons specifically for their psychological impact, rather than simply their destructive capability. Intelligence reports indicated that German units were modifying their tactical procedures and avoiding certain types of operations when rumors circulated about American super machine guns in operational areas. The tactical effectiveness of M2 systems exceeded American expectations, while demonstrating capabilities that fundamentally altered the dynamics of infantry combat in ways that favored American tactical approaches over German defensive doctrine. Units equipped with M2 weapons could engage targets that previously required specialized anti-tank weapons or artillery support, creating tactical flexibility that enabled rapid exploitation of battlefield opportunities. German attempts to develop countermeasures against American heavy machine guns were hampered by incomplete understanding of the weapons' capabilities and tactical employment methods. German defensive planning had been based on assumptions about infantry weapons limitations that proved completely incorrect when confronted with M2 systems that could engage armored vehicles, aircraft, and fortified positions with equal effectiveness. American industrial capacity enabled rapid expansion of M2 production and deployment in response to combat reports that confirmed the weapon's tactical value and strategic impact on German defensive effectiveness. Manufacturing facilities increased production rates while developing improved versions optimized for specific tactical applications, including vehicle mounting, aircraft installation, and specialized anti-aircraft employment. The propaganda value of M2 operations was recognized by American psychological warfare specialists who began incorporating heavy machine gun footage and survivor testimonies into broadcasts designed to demoralize German forces while demonstrating American technological and industrial superiority. German soldiers listening to Allied radio broadcasts heard accounts of weapons that seemed to exceed rational limitations, creating additional psychological pressure on forces already struggling with material shortages and declining morale. German defensive doctrine underwent emergency revision as commanders attempted to develop tactics for defending against infantry weapons that possessed capabilities approaching those of light artillery systems. New regulations emphasized dispersed formations, improved armored protection, and modified operational procedures designed to minimize exposure to devastating American firepower, but these measures proved largely ineffective against determined attacks. Allied forces worldwide began requesting American heavy machine gun technology for their own military units, recognizing that M2 systems provided tactical advantages that could be applied across multiple theaters and operational situations. British, Canadian, and Free French commanders sought access to 50 caliber weapons for breakthrough operations against prepared German positions that had proven resistant to conventional assault methods. The medical documentation of German casualties from M2 attacks provided scientific evidence of wound patterns and trauma effects that informed American understanding of weapon effectiveness while establishing new standards for measuring combat impact beyond simple measures of target destruction. Medical officers noted that M2 attack survivors exhibited injury patterns that differed significantly from those caused by conventional weapons. German prisoner interrogations revealed consistent patterns of fear and demoralization related to encounters with American heavy machine guns, indicating that psychological effects persisted long after physical engagements had ended. German soldiers described nightmares about M2 attacks, anxiety disorders triggered by machine gun sounds, and inability to maintain defensive positions when rumors circulated about approaching American heavy weapons. The strategic implications became apparent as German resistance began deteriorating in sectors where M2-equipped American units operated, creating breakthrough opportunities that accelerated Allied advance rates while reducing casualties through psychological warfare effects that complemented physical destruction. American commanders recognized that heavy machine guns had provided force multiplication effects that exceeded their material costs and logistical requirements. The cultural impact within American forces was profound, as infantry units gained confidence in weapons that provided overwhelming firepower advantages over any German infantry system. American soldiers who had previously operated with caution due to German machine gun superiority suddenly felt empowered by weapons that could neutralize threats while providing sustained fire support for advancing operations. The overwhelming success of M2 heavy machine guns throughout the European campaign established American leadership in heavy infantry weapons technology, while demonstrating the strategic value of industrial capacity that could support mass production and deployment of sophisticated weapon systems on scales that exceeded enemy manufacturing capabilities by enormous margins. The integration of 50 caliber weapons into American tactical doctrine created force multiplication effects that influenced military thinking throughout the remainder of World War II and established principles that guided post-war weapons development. American manufacturing techniques applied to M2 production represented advances in precision engineering, quality control, and mass production efficiency that exceeded German capabilities despite theoretical German advantages in machine tool technology and manufacturing experience. American factories could produce M2 weapons faster, cheaper, and with better consistency than German facilities could manufacture comparable heavy weapons, creating quantitative advantages that multiplied American tactical effectiveness. The technological innovations incorporated into M2 systems included advances in metallurgy, ammunition design, and mechanical engineering that established American superiority in multiple fields related to small arms development. The weapons receiver utilized advanced steel alloys and precision machining techniques that enabled reliable operation under extreme conditions, while maintaining accuracy standards that exceeded those of any comparable weapon system available to any military force during the conflict. The versatility of M2 employment exceeded that of any other infantry weapon available during World War II, enabling effective engagement of personnel, vehicles, aircraft, and fortifications with ammunition types optimized for specific target characteristics. This tactical flexibility meant that American units equipped with M2 weapons could respond effectively to virtually any threat without requiring additional specialized equipment or weapon systems. German attempts to develop comparable heavy machine gun systems were hampered by material shortages, industrial limitations, and strategic priorities that emphasized defensive weapons rather than offensive capabilities that could support mobile operations. German heavy machine gun programs never achieved the reliability, accuracy, or production rates that characterized American M2 systems, creating capability gaps that contributed to German tactical disadvantages. The ammunition technology developed for M2 systems represented significant advances in ballistics, terminal effects, and manufacturing efficiency that influenced civilian and military applications throughout the post-war period. The .50 caliber cartridge became the standard for heavy machine gun employment worldwide, while establishing performance benchmarks that guided ammunition development for decades. International implications became apparent as allied nations worldwide adopted American M2 technology for their own military forces, recognizing that heavy machine gun capabilities provided significant advantages that enhanced tactical effectiveness while reducing casualties through superior firepower and psychological impact. The global deployment of American weapons technology established American leadership in small arms development that persisted throughout the Cold War. The research and development infrastructure created to support M2 production enabled advances in related technologies including aircraft weapons, vehicle armament, and anti-aircraft systems that provided comprehensive advantages across all domains of military operations. The success of land-based heavy machine guns encouraged investment in related programs that established American dominance in automatic weapons throughout the post-war period. Post-war analysis revealed that American M2 employment had achieved tactical advantages that exceeded German comprehension during active combat operations, contributing to psychological effects that accelerated German defensive collapse while reducing American casualties through superior firepower and tactical innovation. German commanders never developed effective countermeasures against weapons that combined surprise, overwhelming firepower, and psychological impact. The economic advantages of M2 production were demonstrated through cost-effectiveness analyses that showed superior performance-to-cost ratios compared to alternative weapon systems that could achieve similar tactical effects. The total cost of M2 deployment was significantly lower than equivalent capabilities provided through specialized anti-tank weapons, artillery systems, or aircraft support, while providing greater tactical flexibility and reduced logistical requirements. The lessons learned from M2 employment influenced American military doctrine regarding firepower, tactical flexibility, and the importance of maintaining industrial capacity that could support innovative weapons development and mass production under wartime conditions. American commanders recognized that technological superiority provided strategic advantages that enabled smaller forces to defeat larger opponents through superior equipment and tactical capabilities. The technological foundation established by M2 development enabled American advances in automatic weapons, ammunition technology, and manufacturing techniques that influenced military and civilian applications for decades. The expertise gained through wartime production established American companies as leaders in small arms development that attracted international customers and provided economic advantages through export sales and technology transfer programs. The transformation of the Browning M2 from an experimental heavy machine gun into the most feared infantry weapon of World War II demonstrated the power of American industrial genius to create capabilities that exceeded enemy understanding and defensive preparation. German forces that had dismissed American infantry as over-dependent on machinery discovered that American machines could deliver firepower that surpassed anything in German tactical experience while providing tactical flexibility that German doctrine had never anticipated. The irony was historically profound and strategically decisive in ways that extended far beyond individual engagements to fundamental questions about the nature of infantry combat and the sources of tactical advantage in modern warfare. German commanders, who had perfected rapid-firing machine gun tactics, found themselves confronting weapons that operated according to different principles: fewer shots, but each shot capable of achieving effects that German weapons required hundreds of rounds to accomplish. The weapon they had mocked for being too heavy became the one they feared the most, demonstrating that American approaches to military engineering emphasized different values than European traditions that prioritized rapid firing rates over individual shot effectiveness. The M2's devastating impact per round created tactical advantages that more than compensated for its lower cyclic rate while providing capabilities that no German weapon could match. The human dimension of this transformation revealed truths about the psychological effects of overwhelming firepower and the importance of technological surprise in achieving tactical success against experienced, well-trained opponents. American crews operating M2 systems gained confidence that enabled aggressive tactics, while German forces experienced demoralization that disrupted defensive coordination and reduced combat effectiveness across wide areas. The strategic implications extended far beyond immediate tactical success to fundamental questions about industrial capacity, technological innovation, and the ability to translate engineering excellence into battlefield advantages that determined campaign outcomes. American success with the M2 proved that superior individual weapons could provide force multiplication effects that enabled smaller units to defeat larger opponents through technological rather than numerical advantages. The ultimate testament to American achievement lay in the speed and completeness with which M2 deployment transformed infantry combat dynamics throughout the European theater, creating tactical conditions that favored American operational approaches while negating German defensive advantages that had been carefully developed through years of combat experience. The weapon became a symbol of American industrial might, translated into immediate battlefield effectiveness. Would you have dared to face the Madus? Stories like this reveal how American engineering could transform theoretical capabilities into practical battlefield advantages that exceeded enemy expectations while providing technological solutions to tactical challenges that conventional approaches could not address effectively. In the next episode, we'll explore another hidden American weapon that caught enemy forces completely unprepared. Subscribe now to uncover more of World War II's hidden secrets.